On the 9th of April, 2026, a 10-year-old girl sent a letter to NASA. Her request was very simple: bring Pluto back as a planet. And the surprising part is that NASA did not dismiss it. NASA Administrator Jared Isaacman said they were considering the possibility of restoring Pluto's full planetary status. But there is one problem. NASA is not the place with the final authority to decide. That authority belongs to the International Astronomical Union, the organization that downgraded Pluto to a dwarf planet in 2006. However, the story does not end there. Nearly 2 decades after that decision, Pluto still refuses to disappear from the human imagination. A small, frozen world located very far from the Sun, yet it made millions of people feel as if they had lost a familiar part of the solar system. So the real question is not only whether Pluto should be called a planet. The deeper question is why this world still makes us argue so fiercely, because when New Horizons flew past Pluto, it did not see a dead, silent ball of ice. It saw ice mountains, nitrogen glaciers, young plains, strange geological traces, and possibly even an ocean buried deep beneath the surface. So, if Pluto is more complex than any single name can describe, is the title Dwarf Planet really enough? And is there any chance that one day, the world once removed from the list of planets could be brought back to its former place? Perhaps what makes Pluto so hard to forget is not only the fact that it was once called a planet. It is the feeling of mystery that has always surrounded this small world. For most of modern history, Pluto was once the final boundary of the familiar solar system. A frozen place, distant, and almost impossible to reach. On average, it's about 5.9 billion kilometers from the Sun. That is a distance large enough to turn Pluto into a faint dot in a telescope, but also far enough for the human imagination to begin filling in what was missing. Yet the strange thing is that even though Pluto was discovered in 1930, it has been visited by only one spacecraft. New Horizons. No fleet of probes. No repeated returns, only one flyby. One brief chance to look closely at a world that humanity had debated for generations. New Horizons was launched in January 2006 from Cape Canaveral Air Force Station. The original mission sounded very clear. Photograph Pluto. Collect data. Observe known moons such as Charon, Styx, and Nix, along with smaller satellites that at the time had not yet been fully discovered, like Kerberos and Hydra. But in space, missions that seem simple on paper are rarely that simple. After 9 years of flying through darkness, New Horizons finally approached Pluto on the 14th of July 2015. And in that moment, a distant point of light suddenly became a real world. Not a dead, silent ball of ice. Not a boring piece of debris at the edge of the solar system. But a surface with ice mountains, with nitrogen glaciers, with canyons, with structures that resemble ice volcanoes. A small place, but not a simple one. So even though New Horizons only flew past Pluto for a very short time, what it sent back was enough to change the way humans looked at Pluto. The problem is that the data did not return as quickly as in science fiction movies. There was no giant screen showing the entire planet in a few seconds. There was no moment of pressing a button and having every secret decoded instantly. The distance was too great. The signal was too weak. The data transmission speed was only about 1 to 2 kilobytes per second. In other words, Each image from Pluto returning to Earth was like a small puzzle piece falling down from the edge of the solar system. And it took 15 months for all the data to be downloaded. 15 months just for humanity to see everything that one flyby had managed to record. But it was precisely that slowness that made the story more fascinating. Each time NASA released a new image, Pluto changed a little more in our eyes. A bright region, a mountain range, an unusually young plain, a geological trace that was not easy to explain. And the closer we looked, the harder it became to dismiss the world that had once been downgraded to a dwarf planet. Because what New Horizons saw on the surface was only the first part of the story. What is more remarkable may be lying deep beneath Pluto's ice. Let's begin with a very strange feature near Pluto's equator. It is called the Brass Knuckles region. This is a chain of 6 dark lowland areas, each averaging about 480 kilometers across, roughly the size of Iceland. From a distance, they look like dark patches scattered across the icy surface, but when viewed more closely, inside these regions is an entire network of interwoven canyons. From west to east, they are called Cthulhu, Ala, Balrog, Vukubkame, Honkame, and Mengpo. These names are all inspired by spirits or forces associated with the underworld in different mythologies. And for anyone who loves The Lord of the Rings, the name Balrog will certainly sound familiar. But the more important point is not in the names. It lies in the reason why these regions are so dark. Scientists think the dark color of the Brass Knuckles region comes from tholins. These are dark organic compounds created when methane and nitrogen on Pluto are affected by cosmic rays over a very long period of time. Tholins appear in many places on Pluto's surface, especially in the large dark region shaped like a whale, known as Cthulhu Macula. But the Brass Knuckles region is not connected into one single patch. Each dark region is separated by ice-covered highlands, rising several kilometers above the surrounding terrain. These highlands may consist of frozen nitrogen, methane, and carbon monoxide sitting on a bedrock of water ice. This may sound strange, but on Pluto, water ice can be as hard as rock because of the extremely low temperature and weak gravity. Meanwhile, nitrogen ice is much softer. It tends to flow downward and fill the lowlands, like slow-moving glaciers on a world cold beyond imagination. So if one were standing beneath those canyons, the surrounding ice mountains would probably look unlike any landscape ever seen on Earth. And it is this contrast between hard ice, soft ice, highlands, and lowlands that will lead us to one of Pluto's most famous features. The difference between the types of ice on Pluto is shown most clearly in its most famous region, the heart-shaped region called Tombaugh Regio, named after Clyde Tombaugh, the man who discovered Pluto. A large part of this region is covered by nitrogen ice, especially the western lobe, where there is a wide and smooth basin called Sputnik Planitia. Looking at it, the surface appears almost flat and bright, very different from the much rougher eastern lobe. If the image is scanned from west to east, the change becomes very clear. On one side is a smooth, icy plain. On the other side is pitted, rugged terrain, almost like the surface of an orange peel. Scientists think that winds on Pluto may carry nitrogen from Sputnik Planitia up into the atmosphere, then deposit it again on the eastern highlands. This could explain why those highlands reflect light more strongly. But the story does not stop there. Some of the nitrogen ice, after being deposited, may slide back down into the lowlands, like a very slow glacier. So the two halves of the heart-shaped region are not merely sitting next to each other. They seem to be exchanging material with each other. One side sends nitrogen upward, the other side receives it and lets it flow back down. It is a strange system, but one that fits Pluto very well. The closer we look, the more this heart-shaped region resembles a surface in motion rather than a layer of ice standing still. And Sputnik Planitia itself will bring the story to a larger question. Why could a plane so far from the Sun look so unusually young and smooth? At the western edge of Sputnik Planitia lies the Al-Idrisi Mons Range. This is one of the strangest landscapes New Horizons ever saw on Pluto. Here, delicate winds push tiny methane ice grains toward the base of the mountains, then deposit them onto the surface like sand. That sounds simple, but it is actually highly unusual. Pluto's atmosphere is so thin that scientists once did not think winds here could transport material in that way. Most likely, the nitrogen ice in Sputnik Planitia sublimated, changing directly from a solid into a gas. This process may have lifted tiny methane particles, carried them into the thin atmosphere, and then allowed them to fall back down near the mountain range. Over time, those methane grains formed a dune field covering about 2,000 square kilometers. At a glance, they may bring to mind the sand dunes of deserts on Earth, but this is not sand, and this is not an ordinary desert. These dunes formed at temperatures of around -230 degrees Celsius. Methane grains are much lighter than sand, and in Pluto's low gravity, they would probably feel like cold dust slipping through your fingers. Of course, at that temperature, it is best not to try. But the methane dunes are not the strangest thing at the edge of Sputnik Planitia. Very close to this mountain range, there is also a deep trench, and that trench may be pointing to something happening beneath Pluto's icy crust. But the methane dunes are not the only remarkable feature at the edge of Sputnik Planitia. To the west of the Al-Idrisi Mons Range, there is also a deep trench. On elevation maps, this trench appears as a dark blue band lying right against the foot of the mountains. The strange thing is that the height of the mountains changes depending on their location. The peaks near the trench are only about 200 meters to 1 kilometer high. But the farther they are from the trench, the taller the peaks become, with some reaching around 3 kilometers. That is not just a topographic detail. It may be a sign that the icy crust in this region was once shifted, uplifted, or deformed in some way. And if Pluto's surface truly has been shaped in that way, a larger question begins to emerge. What is happening below? One of the most fascinating hypotheses about Pluto is that this small world may once have had, or may even still retain, a subsurface ocean beneath its icy crust. That idea sounds almost absurd. Pluto is far too distant from the Sun. It is even smaller than Earth's moon. At that size, its core would not be expected to generate much heat. But for liquid water to exist beneath the surface, Pluto would have to retain enough heat from radioactive decay in its interior. So if these topographic traces really are connected to a subsurface ocean, then Pluto is not just a frozen world at the edge of the solar system. It may be a world that still preserves some deep internal activity, and the deep trench beside Al-Idrisi Mons may be only the first sign. A 2019 study presented at the Lunar and Planetary Science Conference suggested that this mountain range may have shifted eastward through solid-state convection. Put more simply, the solid ice beneath it may have deformed and drifted extremely slowly over time. If that is true, this movement may have created the deep trench to the west of the mountain range. At the same time, it could also explain why the peaks farther from the trench become taller. This is an important detail, because a surface that can shift in this way does not resemble a dead, motionless layer of ice. It suggests that beneath Pluto's crust, there may once have been a system warm enough, soft enough, and dynamic enough to deform the terrain above it. And if this hypothesis is correct, it would strengthen the possibility that Pluto has a layer of liquid water lying deep beneath its icy crust. But the deep trench and the shifted mountain range are not the only signs. Elsewhere on Pluto, New Horizons also saw structures that resemble ice volcanoes. The deep trench is not the only sign that Pluto may once have been more active than it appears. New Horizons also saw structures that resemble ice volcanoes. One of them is Right Mons. In the highest resolution color images stitched together by the New Horizons team, Right Mons appears as a gigantic mountain of water ice. It rises about 4 kilometers high. At its center is a large depression, like a collapsed crater. What makes this structure notable is that the surrounding area has very few impact craters. That suggests the surface here may still be fairly young, or may have been resurfaced in the more recent geological past. To the southwest of Right Mons, there is another, even larger structure, Picard Mons. It may rise as high as about 7 kilometers. Unfortunately, when New Horizons imaged this area, Picard Mons was already in shadow, so the images are not as clear as those of Right Mons. But on topographic maps, one detail still stands out. It also has a large central depression. These two depressions are reminiscent of collapsed volcanic craters on Earth. But on Pluto, if these really are ice volcanoes, what erupted would not have been molten rock. It may have been water, soft ice, or ice-rich material pushed up from below. Looking more closely, there are also concentric rings around the depressions. They may be traces of multiple eruptions, followed by the material inside draining away and the crater collapsing. Of course, scientists still have not confirmed with certainty that Right Mons and Picard Mons are ice volcanoes. But the signs are beginning to pile up. A deep trench, a shifted mountain range, a young surface, structures with enormous collapsed openings. And all of them point to the same question. If Pluto truly has activity beneath its icy crust, what else is this small world hiding? From all of those signs, it becomes clear that Pluto is not a simple world. It has ice mountains, it has nitrogen glaciers, it has methane dunes, it has deep trenches, young surfaces, and structures that may be connected to activity beneath the icy crust. A place this small should have been cold, quiet, and almost motionless. But New Horizons showed the opposite. Pluto is a beautiful, complex world, and one that is difficult to dismiss, but none of that has answered the most important question. Does Pluto deserve to be called a planet? To understand why this question is still so controversial, the story must return to 1978. Not with a clear photograph, not with a new space mission, but with a discovery that at first seemed like nothing more than a flaw on an image. That was where Charon entered the story. The story of Charon did not begin with a major search. It began with a photograph that was thought to be flawed. On the 22nd of June 1978, James Christie, an astronomer at the United States Naval Observatory, was examining photographs of Pluto to refine its orbit around the sun. This was ordinary work. Slow, repetitive, and with no sign that it would change history. Those photographs were taken with the number 5 meter Kaj Strand telescope in Arizona. The quality was not exactly good. Some of the plates had even been marked as poor because Pluto did not appear as a neat point of light. Instead, it looked like an elongated streak of light with a strange bulge on one side. To most people, that was just image noise. Maybe caused by the atmosphere, maybe caused by the telescope not being aligned precisely, a small flaw that should be ignored. But Christie did not see it that way. He had a great deal of experience photographing binary star systems, so that bulge looked very familiar. Then he noticed one important detail. Pluto was blurred, but the background stars behind it remained sharp. If the flaw had come from the telescope or the atmosphere, everything in the image should have been distorted. But that was not the case. Only Pluto had a problem. That meant the bulge might not have been a flaw. Something real might actually have been sitting beside Pluto, and that small discovery on what seemed to be a damaged photograph would change the entire way humans understood this distant world. Christie did not stop with one photograph. He began digging through the observatory's archives, looking for photographs of Pluto taken as far back as 1965. Many of those plates had also once been considered flawed. Some were even annotated with notes saying that Pluto's image appeared elongated. But now, the photographs that had once seemed useless became evidence. Christie realized that the bulge was not staying still. It moved around Pluto over time. Together with his colleague Robert Harrington, he tracked its position through years of old data. The result was very clear. That bulge orbited Pluto every 6.4 days. And this number matched Pluto's known rotation period. That was the final piece of the puzzle. What had once been considered an image flaw was not noise. It was a real celestial body, a large moon locked in synchronized motion with Pluto. The new moon was temporarily called S1978P1. As the discoverer, Christie had the right to propose a name for it. He chose the name Charon, inspired by the name of his wife, Charlene, whose nickname was Char. He added an ending similar to the names of particles in physics, such as proton or electron. It was a deeply personal name, but strangely enough, it fit perfectly with mythology. In Greek mythology, Charon is the ferryman who carries the souls of the dead across the river Acheron into the underworld ruled by Pluto. That name was officially approved by the International Astronomical Union in 1986. But Charon was not just a newly named moon. Its existence would force scientists to recalculate Pluto's mass, and from there, it would shake Pluto's position on the list of planets. But Charon was not just a new moon. Its existence forced astronomers to look at Pluto all over again. And the first discovery changed a great many things. By tracking Charon's orbit, scientists could use Kepler's laws to calculate the mass of the entire Pluto-Charon system. The result was much smaller than people had once thought. Pluto was not a small rocky planet with significant mass. It is only about 1/6 the mass of Earth's moon. And Charon is far too large compared with the world it orbits. This moon has about 12% of Pluto's mass. For comparison, our moon has only about 1.2% of Earth's mass. That difference makes the Pluto-Charon system highly unusual. Normally, when a small moon orbits a large planet, the center of mass of the two lies deep inside the planet. The planet only wobbles slightly. The moon is the object that moves in a large orbit. But with Pluto and Charon, things are not that simple. Charon is large enough to pull the center of mass of the entire system outside Pluto. That point lies in empty space, about 960 kilometers above Pluto's surface. So Pluto and Charon do not look like a stationary planet with a small moon orbiting around it. They look like two worlds revolving together around an invisible point in space, and that leads to an even stranger feature. Both are tidally locked to each other. Earth's moon is also tidally locked, so we always see the same side of it. But the Pluto-Charon system goes further. Charon always turns the same face toward Pluto, and Pluto also always turns the same face toward Charon. If you stood on the side of Pluto facing Charon, this large moon would hang fixed in the sky. It would not rise. It would not set. It would simply stand there like a gigantic disk staring forever down at the icy surface. And if you stood on the other half of Pluto, you would never see Charon. Not once. These two worlds are locked in an eternal gaze, separated by about 19,640 kilometers. And it was this unusual relationship that forced scientists to ask a more difficult question. Is this truly a planet and a moon, or is it a binary system? These two details make the Pluto-Charon system very difficult to classify. Their center of mass lies outside Pluto, and both always keep the same face turned toward each other. For that reason, some scientists argue that this should not simply be considered a planet and a moon. It may be more like a binary planet system. That very ambiguity became an important part of the debate over the definition of a planet in the early 2000s. Charon provided data that astronomers could not ignore. Pluto was much lighter than originally imagined, and the Pluto-Charon system behaves in a way unlike the familiar planet-moon systems. That forced the scientific community to face an uncomfortable truth. The solar system is more complex than the simple labels humans place on it. In 2006, the International Astronomical Union even considered the idea of calling Pluto and Charon a binary planet system. But that proposal was eventually set aside, because at that time a larger decision was being made. And that decision would change the way millions of people called Pluto. From a planet to a dwarf planet. So, how did that happen? Before 2006, the word planet was used quite broadly. It mainly referred to large objects orbiting the Sun. But that was an old way of naming things, formed long before humans clearly understood the outer edge of the solar system. And then the problem began to appear. While Charon made astronomers realize that Pluto was smaller and lighter than imagined, telescopes also began finding many other objects beyond Neptune's orbit. Quaoar, Sedna, Makemake, and especially Eris. At that time, Eris was once thought to be larger than Pluto. Later measurements showed that Eris is slightly smaller, with a diameter of about 2,326 kilometers, compared with Pluto's roughly 2,377 kilometers. But Eris has more mass, and this is the problem. If Pluto is a planet, then is Eris a planet? What about Makemake? What about Sedna? If things continued that way, the list of planets would not stop at 9. It could keep growing longer. So the International Astronomical Union had to create a clearer definition. In 2006, they set 3 criteria. An object must orbit the Sun. It must have enough mass to pull itself into a nearly round shape. And it must have cleared the neighborhood around its orbit. The first 2 criteria were not a major problem for Pluto. It orbits the Sun. It is round enough. But the third criterion was the decisive point. Pluto has not cleared its orbital neighborhood. It shares that region with many other objects in the Kuiper Belt, including Plutinos and large bodies such as Orcus and Lempo. So Pluto no longer met the new definition of a planet. Charon did not directly take away Pluto's planetary status, but this discovery was an important domino. It showed that Pluto was lighter, stranger, and harder to classify than people had once thought. And as new objects beyond Neptune continued to appear, The question was no longer whether Pluto was special. The question was what we should call all of those worlds. But Charon did not only change the way humans classified Pluto. It also raised another question, one much deeper. How did a strange system like Pluto and Charon form in the first place? So, how did a strange system like Pluto and Charon form? For many years, the most popular explanation was the giant impact hypothesis. This idea is quite similar to the way scientists explain the birth of the Moon. A large object in the Kuiper belt may have struck Proto-Pluto. That collision would have blasted a large amount of debris into orbit. Over time, these fragments came together and formed Charon. This model explains several important things. It helps explain the high angular momentum of the Pluto-Charon system. It also fits Charon's nearly circular orbit. But then, problems began to appear. Pluto and Charon were not like the early Earth. They were not molten rocky bodies. They were small, rigid worlds made of rock and a great deal of water ice. And water ice does not respond to impacts the same way molten rock does. As newer simulations became more detailed, another scenario began to look more plausible, not a completely destructive impact, but a slower, less violent grazing collision. In this scenario, Proto-Pluto and Proto-Charon collided gently enough that they were not crushed apart. They temporarily stuck together. For a few hours, the two objects may have spun through space like a giant snowman-shaped body. Then tidal forces pulled them apart, but not completely apart. They were still held by gravity and became the binary system we see today. The strength of this model is that it preserves the separate nature of both worlds. Pluto is denser and richer in rock, with about 70% rock. Charon contains less rock, about 55%. That suggests they were not completely mixed together in a violent collision. They may have formed as two separate objects, then became bound together after a very unusual encounter. But this story does not only explain Charon's orbit, it may also explain why Charon was once a far more geologically active world than it appears today. The initial collision injected energy into the interiors of both bodies. Then, as they stretched and exerted tidal effects on each other during the process of separating, a large amount of heat may have been generated deep inside. That heat source may have melted part of the ice layer beneath Charon's crust. And if this is true, Charon may once have had a subsurface ocean. An ocean buried beneath an icy shell. An ocean that left traces on the surface long after it began to freeze. And when New Horizons flew past Charon in 2015, those traces finally came into view. For 37 years after its discovery, Charon was almost nothing more than a faint shadow beside Pluto. A small dot, a distant companion. But on the 14th of July 2015, New Horizons flew past the Pluto-Charon system. And everything changed. Charon was no longer a point of light in a telescope. It became a real world, a world with a surface that had been torn apart. The images sent back by New Horizons showed that Charon was not smooth at all. Its surface is filled with large fractures, cliffs, mountain ridges, and deep valleys. Most prominent is a system of chasms running near the equatorial region, including Serenity Chasma. This system stretches at least 1,800 kilometers and reaches depths of up to 7.5 kilometers in some places. For perspective, it is more than 4 times longer than the Grand Canyon and nearly 5 times deeper. But this is not a canyon carved by a river. Charon has no rivers flowing across its surface. These are enormous extensional fractures. signs that Charon's crust was once stretched beyond what it could endure. So what force could make an entire small world crack apart like that? The answer may lie in its lost ocean. After it formed, Charon may have retained enough internal heat from the initial collision, tidal friction, and radioactive decay in its rocky core. That heat source could have melted water, ice, deep beneath the crust, creating a subsurface ocean. For a time, Charon may once have been an ocean world, but Charon is too small to hold on to heat forever. Over millions of years, it gradually cooled. The ocean beneath began to freeze. And this is the important point. Water expands when it freezes. As the ocean turned into ice, the volume inside increased and pushed the overlying crust outward. The surface was stretched, the cracks widened. Eventually, Charon's crust broke apart, leaving behind the enormous chasms that New Horizons sees today. At present, Charon appears to be much quieter. There is no thick atmosphere to blur these traces. There is no strong geological activity to bury the past. So, those fractures are still there, like a frozen record of the moment Charon's ocean died. But as that ocean froze, it did not only tear the crust apart, it may also have resurfaced a large part of Charon's surface. When Charon's ocean froze, it did not only crack the crust apart, it may also have resurfaced a large part of the surface. New Horizons showed that Charon is like a world divided into two different stories. To the north is Oz Terra. This is an older, higher, rougher terrain, full of impact craters and cut across by large fractures. It resembles Charon's old crust, preserved in a fractured state after the interior expanded. But toward the south, the landscape changes clearly. That is Vulcan Planitia, a vast plain, lower and much smoother than the northern region. This area has fewer impact craters, so it may be geologically younger. Its surface also contains traces that resemble frozen flows. And this is the important point. Scientists think Vulcan Planitia may be one of the largest examples of cryovolcanic activity in the solar system. Not volcanoes erupting molten rock, but water, soft ice, and ice-rich material pushed up from below. As the subsurface ocean froze, it expanded and increased the pressure on the remaining liquid beneath the crust. That liquid may have been mixed with ammonia, helping it resist freezing. Under great pressure, this material may have been forced upward through fractures, then spread across the surface like icy lava. Over time, those flows may have created the young, smooth plains in the southern hemisphere. This region also contains isolated mountains, such as Kubrick Mons. They sit inside very strange surrounding depressions or moats. One possibility is that these are blocks of old crust that broke apart, drifted along with icy flows, and then became trapped when the surface hardened. If that is true, Vulcan Planitia is not just a plain. It may be the trace of a moment when Charon partially remade its own surface. But Charon still has another mystery, one more striking than all the rest. A dark red stain lying directly over its north pole. The most striking mystery on Charon lies at its north pole. It is a large, dark red region, unofficially called Mordor Macula by the New Horizons team. The name has a mythological tone, but that red color may come from a very real chemical process. Scientists think it is created by tholins, the same kind of dark organic compounds that also appear on Pluto. But the question is where the methane came from. There are currently two main hypotheses. The first hypothesis suggests that the methane came from Pluto. Pluto's thin atmosphere is slowly escaping into space, carrying nitrogen and methane with it. As Charon orbits, it may capture some of that escaping gas. During a polar winter lasting more than a century, temperatures at Charon's North Pole can drop below -240 degrees Celsius. At this level of cold, methane becomes trapped and freezes directly onto the surface. Then, when sunlight returns, ultraviolet radiation transforms the frozen methane layer into dark red tholins. If that is true, Pluto is quietly painting its largest moon. But there is another possibility. The methane may have come from inside Charon itself. The icy eruptions that once created Vulcan Planitia may have released methane gas from an ancient subsurface ocean. That gas could have formed a temporary atmosphere, then migrated toward the coldest regions at the two poles. Over billions of years, radiation transformed the methane and left behind the red stain that New Horizons saw. Whether the methane came from Pluto or from inside Charon, Mordor Macula still shows one thing very clearly. These two worlds cannot be understood separately. Charon's history has always been tied to Pluto, from its orbit to its surface to the very color of its North Pole. And that is why the story of Charon is not just the story of a moon, it is the key to understanding the entire Pluto system. Charon's journey began with a blur on a photograph, a detail that was almost dismissed as a technical flaw. But in the end, that blur opened up an entire world. Charon is not only Pluto's largest moon, it is a place with enormous chasms, young icy plains, traces of ancient cryovolcanism, and a dark red polar region that still has not been fully explained. The story of Pluto cannot be told while leaving Charon out. It was Charon's orbit that helped astronomers measure Pluto's true mass. And that measurement showed that Pluto was not like a familiar planet. It is the largest representative of a new group of worlds at the edge of the solar system. The existence of Charon also suggests that these two worlds may have been born from an ancient collision, an event that not only shaped their orbits, but also injected heat into their interiors, driving the geological history of the entire system. Charon's fractured surface tells the story of a lost ocean, and its red polar region may be the long-lasting trace of methane gas, coming either from Pluto or from inside Charon itself. Every clue points to the same thing. Pluto and Charon are not two separate objects. They are a tightly bound system, from gravity to origin to surface to chemical history. And it was Charon, the moon once discovered as an image flaw, that made the question of Pluto far more difficult. If such a small world has a system this complex, then does the name dwarf planet truly capture its nature? There is one final question that needs to be returned to. Charon may have helped open the path that led to Pluto being downgraded to a dwarf planet, but will that story remain that way forever? Could Pluto one day be called a planet once again? There is a reason this question is still alive. The current definition of a planet relies heavily on whether an object has cleared the region around its orbit around the Sun, and this is the controversial point. Earth still has thousands of asteroids near its orbit. Jupiter also shares its orbit with a large number of Trojan asteroids. So, if Pluto fails because it has not cleared its orbital neighborhood, is that criterion really clear enough? Some scientists argue that the issue should be viewed differently, not only by asking how well an object has controlled its orbit, but also by asking whether it is a complex world. Pluto has ice mountains, it has nitrogen glaciers, it has young geological traces. It may have once had, or may still have, a subsurface ocean, and it has Charon, a companion so large that the two of them revolve around a shared point in space. So, if the definition of a planet has changed once before, there is no guarantee that it will never change again. After all, planet is a name created by humans. It does not make Pluto any less real. Nor does it make the ice mountains, the nitrogen plains, or Charon's red polar region disappear. Whether it is called a planet, a dwarf planet, or a world of the Kuiper Belt, Pluto remains one of the strangest and most fascinating places humans have ever seen at the edge of the solar system. And perhaps that is what matters most. Not the name we assign to it, but the question it forces us to ask: how can a world so small, so frozen, and so distant be complex enough to make even our definition of a planet begin to shake? Thank you for staying with Astrexo until the end of this journey. If this video helped you see Andromeda in a different way, leave a like, share your thoughts below, and subscribe to the channel to continue following the next journeys through the universe. See you again in the next video from Astrexo.